Hello viewers, welcome to the lecture series of SSC Quantitative Aptitude. This is your tutor Keshav Agarwal, and in this lecture we are going to study fundamental arithmetic operations and BODMAS rule. So this is going to be part 1. So in this lecture, first of all, we are going to study approximation, and in approximation we will study concept of approximation, and then we will study properties of approximation, in which the first property that we are going to study is rounding of numbers, estimation, decimal approximation, and then we will move to simplification. So in simplification we are going to start with concept of simplification, then we will see some properties of simplification like order of operations, simplifying fractions, exponent rules, square and cube of numbers. And the third section that is available in this lecture is types of questions. So first type of question we are going to see are rounding off and estimation. Secondly, we will see decimal approximation. And third, we are going to study simplifying expressions. Fourth is fraction simplification. Then we will study percentage approximation. And sixth is approximate calculation, simplification of equations, squaring and cubing, and at last conversion approximation. And after we have studied all these topics, we will see some questions on the topics which we have studied. So let us get started. So approximation. These concepts involve estimating or rounding of numbers to make calculation easier and quicker. In real-world scenarios, exact calculation may not always be necessary and approximate answers are often sufficient. So if I have to give you a definition of approximation, it would be approximation is a process of finding a close value of a quantity, number, or an expression that is easier to work with or understand compared to its exact value. So overall, we can say that the main motive of approximation is to get a quantity that is easier to work with or to understand. So moving on to properties of approximation. So first of all, rounding off numbers. In approximation, we often round off numbers to a certain decimal place or significant figure. In estimation is a valuable technique in approximation where we use rough calculations to get close approximate values. And the third property is decimal approximation. For example, root 2 is approximately 1.4. Root 2 is obviously an irrational number and it goes on and on as we have studied in number systems. So root 2 is approximately 1.41 and pi is approximately 3.14. Again, pi is also an irrational number. So it's non-recurring, non-terminating, but still we often use as 3.14 and so on. So concept of simplification. Simplification helps in obtaining concise and clear solutions, making mathematical operations more efficient and understandable. So what are properties of simplification? The very first property of simplification is order of operations. So simplification follows the BODMAS rule, in which B stands for bracket, O stands for off, D stands for division, and M stands for multiplication, and A stands for addition, and S stands for subtraction. And BODMAS rule to solve expression step by step. Second property is simplifying fractions. Reduce fractions to their simplest form by cancelling out common factors in the numerator and denominator. Third property is exponent rule. Simplify expressions involving exponents using rules like a to the power m into a to the power n is equal to a to the power m plus n, and a to the power minus m is equal to 1 upon a to the power m. And the fourth property is square and cube of numbers. So it is suggested that learn the square and cubes of common numbers up to a certain range to simplify calculation. So it will help us to make our calculations faster, and we will be able to obtain the result easily and quickly. So now let us move ahead to types of questions. So first of all, rounding off and estimation. Questions were questions where candidates need to round off numbers to a certain decimal place or use estimation techniques to obtain approximate values. For example, approximate the value of root 15 to the nearest whole number. So we have to approximate root 15. Root 15 does not is not equal to any real number or a perfect number, I should say, or the whole number, because when we square any whole number we'll never get 15. So we need approximate value, because working with root 15 may get tedious sometimes. So the approximate value of root 15 to the nearest whole number is root 16, because root 16 is very close to root 15. So root 16 is equal to 4. Okay, so that is already known to us. So we can say that approximate value of root 15 is 4. It is not equal to 4. That's why we have use this wavy equals to represent approximate value here. Okay, so let us move ahead and study another type of questions, that is decimal approximation. Questions involving the approximation of square roots, cube roots, and other irrational numbers to a specific decimal place. So, for example, find the approximate value of pi correct to 2 decimal places. So, pi is a non-terminating, non-recurring decimal number. Okay, so it goes on and on, but we often use, you have already seen in books that we often use 3.14. So pi is approximately equal to 3.14, not exactly but approximately equal to. Third type of questions is simplifying expressions. So questions requiring candidates to simplify complex mathematical expressions using BODMAS rule and various algebraic properties. For example, simplify the expression 3 plus 5 into 2 minus 4 plus 6 by 3. So the solution is 3 plus 5 times 2 minus 4 plus 6 by 3, which is equal to 3 plus 5 is 8 and 2 minus 4 is minus 2. So 6 by 3 is 2. So, but we are not doing it right now. So first of all, we are resolving brackets. That's what BODMAS rule says. So we are resolving brackets first. Okay. So 8 times minus 2 plus 6 by 3. And again, it will be minus 16. And then we will do division this time. So 6 upon 3 is 2. And according to BODMAS rule, now we can do addition. So it will be minus 6 plus 2, which is equal to 14, minus 14. So the correct answer is minus 14. Fourth type of questions that are asked is fraction simplification. Questions involving the reduction of fractions to their simplest form by cancelling common factors. So for example, simplify the fraction 24 by 36 to its simplest form. So the solution is the greatest common divisor, GCD, of 24 and 36 is 12. So divide both the numerator and denominator by 12, we get 2 upon 3. The fifth type of questions that are asked is percentage approximation. Questions where candidates need to find approximate percentages of numbers without using a calculator. So without using a calculator, find 15% of 80. So 15% of 80 is equal to 15 upon 100 into 80, which is equal to 0.15 times 80, and it is equal to 12. So 15% of 80 is 12. The sixth type of questions that are asked is approximate calculations. So questions requiring candidates to perform calculations involving addition, subtraction, and multiplication and division. For example, calculate 15 to the power 1 by 2 minus 2 approximately. So, as you remember, in the previous slides, we have seen 15 to the power 1 by 2 is exactly cannot be computed very easily. We have to put all efforts, and working with 15 to the power 1 by 2, root 15 can be tedious. So we approximated it to root 16, which is equal to 4. So that is exactly what we are going to find the approximate value of this thing. So root 15 minus 2 is approximately equal to root 16 minus 2. And root 16 is 4. So 4 minus 2, it is 2. Now, moving on to seventh type of problem that are asked, it is simplification of equations. To simplify algebraic equation and expression to find the value of a variable. For example, solve for x in the equation 2x plus 5 equal to 17. So the solution, subtract 5 from sides to isolate 2x. So it will be 2x plus 5 minus 5, 17 minus 5. So it will be 2x equal to 12. And now divide both sides by 2 to solve for x. So x is equal to 12 upon 2. Now, the eighth type of questions that are asked is squaring and cubing. Questions involving simplification of squares and cube expressions to obtain the final result. For example, simplify the expression 4x whole square. So 4x whole square can be written as 4 square times x square, which is equal to x square times 16 times x square. Ninth type that is asked in the question is conversion approximation. Questions requiring candidates to approximate when converting between different units. For example, convert 25 miles to kilometer, approximating the conversion factor as 1 mile equal to 1.6 kilometers. So 25 miles is approximately equal to 25 times 1.6 kilometers, which is equal to 40 kilometers. So that was all about types of questions that are asked. Now we can see some exercise solved problems based on fundamental arithmetic operations and BODMAS rule. So the first question is, evaluate 1 upon 15 plus 1 upon 35 plus 1 upon 63 plus 1 upon 99 plus 1 upon 43. So let us see the solution. So the sum of fractions is given to us is 1 upon 15 plus 1 upon 35 plus 1 upon 63 plus 1 upon 19 plus 1 upon 43. So expressing each fraction in its prime factorization form. So we will get 1 upon 3 times 5 plus 1 upon 5 times 7 plus 1 upon 7 times 9 plus 1 upon 9 times 11 plus 1 upon 11 times 13. So we will have 1 by 2 times of 1 by 3 minus 1 by 5 plus 1 by 5 minus 1 by 7 plus 1 by 7 minus 1 by 9 plus 1 by 9 minus 1 upon 11 plus 1 by 11 minus 1 upon 13. And here this and this can get cancelled, this and this get cancelled, this and this will get cancelled, this and this is also going to get cancelled. So we will be left with 1 upon 2 times 1 upon 3 minus 1 upon 13. So you can do cross multiplication here, or you can take LCM. So 1 upon 2 times 10 upon 39, which is equal to 5 upon 39. So the correct option here in this question will be option number B. Moving on to problem number 2. Find the value of 1 plus 1 by 2 times 1 plus 1 by 3 times 1 plus 1 by 4 1 plus 1 by 120. So the solution. So here we are provided with an expression of 1 plus 1 by 2 times 1 plus 1 by 3 times 1 plus 1 by 4 1 plus 1 by 20, which can be rewrite as 2 upon 2 plus 1 by 2 3 upon 3 plus 1 by 3. We are just replacing these ones. Okay. We are playing smart here and we are replacing these ones only with the number which is given here. So because 4 upon 4 is 1 only, so it will not change anything. That's the beauty of mathematics. So 1 upon 20 upon 1 upon 20 plus 1 upon 120. So and this will simplify to 3 by 2 times 4 by 3 times 5 by 4 dot 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 121 upon 120. So now observe the pattern of cancellation. The 3 in the denominator of first term cancels with the 3 in the numerator of the second term. The 4 in the denominator of second term cancels with the 4 in the numerator of third term. This pattern continues, leading to most terms cancelling each other out except for the 2 in the denominator of the first term and 121 in the numerator of the last term. After all the cancellations, we are left with 121 upon 2, that is equal to 60 upon 5. So the value of the product which was given to us initially is equal to 60 upon 5, that is option number C. Let us now move to problem number 3. 999 times 999 of 1/7, 999 of 2/7, 999 of 3/7, and till 6/7. We have to simplify this. So the sum of mixed numbers can be simplified by separately summing the integer part and the fractional parts. So the numbers 999 of 1/7, 999 of 2/7, 999 of 3/7, and 999 of 4/7. So this will be we are going to separate the integer parts and the fractional part. So add the integer parts, which will be 999 plus 999 6 times. So which is 6 into 999, and add the fractions separately like this, which is done here. So adding the fractions separately, you will get 21 upon 7. And now combine the sum of integer part and the fractional part, which is 6 times of 999 plus 21 upon 7. So calculate the sum, you will have 5994 plus 3, which is equal to 5,997, which is option number A. Now moving to problem number 4. So in this problem, we have 1 upon 1 into 4 plus 1 upon 4 into 7 plus 1 upon 7 into 10 plus 1 upon 10 into 13 plus 1 upon 13 into 16. So we have to find the sum here. So the solution here, taking 1 upon 3 common, we will have 1 upon 1 minus 1 upon 4, because if you see, it is nothing but 3 upon 4, correct? This thing is actually 3 upon 4 and we have taken 3 common. So we are actually doing correct here. So the second term becomes 1 upon 4 minus 1 upon 7. The third term becomes 1 upon 7 minus 1 upon 10 and plus 1 upon 10 minus 1 upon 13 plus 1 upon 13 minus 1 upon 16. So now here you can see that the 1 upon 4 is getting cancelled, minus 1 upon 7 get cancelled, 1 upon 10 also get cancelled, 1 upon 13 also get cancelled here. So you are left with 1 upon 1 minus 1 upon 16, which is equal to 1 upon 3 into 15 upon 16. On simplifying, you will have 5 upon 16. So the correct answer here will be option number B. So let us move ahead to question number 5. So in the question number 5, we have 1 upon 3 times 5 plus 1 upon 5 times 7 plus 1 upon 7 times 9 plus 1 upon 9 times 11 plus 1 upon 11 times 13 plus 1 upon 13 times 15. So again, taking 2 common here, and the fractions can be written as 1 upon 3 minus 1 upon 5, 1 upon 5 of minus 1 upon 7 plus 1 upon 7 minus 1 upon 9 plus 1 upon 9 minus 1 upon 11 plus 1 upon 11 minus 1 upon 13 plus 1 upon 13 minus 1 upon 15. So if you see closely or observe the expression, you will see 1 upon 5 is getting cancelled, 1 upon 7 is getting cancelled, 1 upon 9 is getting cancelled, 1 upon 11 is also getting cancelled, 1 upon 13 is also getting cancelled. So here you are only left with 1 upon 2 times of 1 upon 3 minus 1 upon 15, which is equal to 1 upon 2 times of 4 upon 15. That is equal to 2 upon 15. So the correct option here is option number D. Now, question number 6. 1 minus 1 upon n plus 1 plus 1 upon 1 minus 2 upon n plus 1 plus 1 minus 3 upon n plus 1 plus dot 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 plus 1 minus n upon n plus 1. So we have to find the sum, this expression value here. So if you see, 1 is repeating everywhere. Okay, so 1 is repeated here, 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 and here. So we can club all these ones, and these all 1 are written n times. So we can write it as 1 plus 1 plus 1 plus 1 plus n times. Okay, and the rest thing, you can see n plus 1 is in the denominator, and we can combine all of them to write 1 plus 2 plus 3 plus till n upon n plus 1. And now try to recall the sum of first n natural numbers. It is equal to n times n plus 1 upon 2. That is exactly what is written here. So this sum is going to be n, and on simplifying, this and this get cancelled. You will have n minus n upon 2. So it will be n upon 2. So the correct answer here is option number B. Given 2 square plus 4 square plus 6 square till 40 square is equal to 11480. So the value of this sum is given to us, and using this sum, find the value of 1 square plus 2 square plus 3 square plus till 20 square. So this value is given to us, 2 square plus 4 square plus 6 square plus dot 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 plus 40 square equal to 11480. So we have to find the value of this thing. So you observe that 2 square is common in each of these. So we can take 2 square common. So we will have 1 square plus 2 square plus 3 square plus dot 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 20 square. And now if you see, this is exactly what was asked in the question in the first place. So you just have to send this 2 to the right hand side, and you will have 1 square plus 2 square plus till 20 square is equal to 11480 upon 4. And on simplifying, it will be 2870. So the correct answer here will be option number B. And similar to the previous problem, in this also, 1 square plus p, 2 square plus 3 square equal to dot 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 p square is given to us, which is equal to p times of p plus 1, 2p plus 1 upon 6. This sum is given to us. Then 1 square plus 3 square plus 5 square till 17 square is equal to. So we have to find this new sum here. So this sum which we want to compute can be rewritten as, because if you see, the even terms are missing, only the odd terms are included, correct? So what if I include the even terms? So if I have to include the even terms also, I have to reduce that number here also. Okay, so if I want 2 square in between them, so I will add plus 2 square, then I have to write minus 2 square also. So doing the same, we will have 1 square plus 2 square plus 3 square plus 4 square plus 5 square till 17 square, and minus of 2 square plus 4 square plus 6 square till 16 square. Okay, so this thing can be written as 1 square plus 2 square till 17 square minus 2 square can be taken out common. So it will be 1 square plus 2 square plus 3 square till 8 square. So by using the formula, it will be 17 times 18 times 35 upon 6 minus 8 times 9 times 17 upon 6. And on simplification, you will get 969, and the correct option here will be option number A. Moving to problem number 9. Triple one of 1 half plus triple one of 1 6 plus triple one of 112 plus triple one of 120 plus triple one of 130. We have to find the sum here. So the sum of mixed fractions, mixed numbers can be simplified by separately summing the integer part and the fractional part. So this thing we have already seen in previous questions. So I will take the sum of all triple ones which are written 5 times. So it is 5 of 5 into triple one. Okay. And the rest of the numbers are rest of the fractional parts summing together. It will be 1 upon 2 plus 1 upon 6 plus 1 upon 12 plus 1 upon 20 plus 1 upon 30, which is equal to 50 upon 60. So combine all of them together. So 5 into triple one plus 55 upon 60, it is triple five plus 55 upon 60, which is equal to triple five of 5 sixes. So the correct answer here is C. So the last problem of this lecture, find the value of 3 upon 18 of 3 into 6 plus 21 into 6 upon 18 minus 3 upon 2 plus 3 minus 3 upon 9 of 3 into 9. So the solution, 3 upon 54, 18 times of 3 is 54. So 3 upon 54 6 times 6 plus 21 times 6 upon 18 minus 3 upon 2 plus 3 minus 3 upon 9 of 3 means 9 times 3 is 27 times 9. And if you simplify them, this and this get cancelled here. Okay. And you will have 1 upon 3 plus 7 minus 3 by 2 plus 3 minus 1. And finally, you will have 47 by 6. So the correct option here is option number D. So thank you very much. And this would be all for this lecture. And I'll see you in the next lecture with more problems on the same topic.